My name is Murli Bharadwaj, and this is my Lab 2 presentation.
In this lab, I observed and measured the concept of charge in everyday household objects. I applied physics fundamentals including equilibrium, experimental design, and electric force concepts. The primary goal of the lab was to determine the amount of excess charge on a piece of charged tape. In the process, I learned how to induce charge on an object, I observed how charged objects interact with other objects, and I determined the type and amount of charge on an object.
The materials included in this lab were clear Scotch tape, 2 shoe boxes of equal height, a plastic ball pen, a ruler, and a piece of cloth.
The lab procedure began with the creation of the U-tape and the base tape. I cut out 2 pieces of clear Scotch tape and labeled them as the base tape and U-tape. I then placed the base tape on the table surface. I created a handle on the U-tape as shown in figure 1 and attached the U-tape to the base tape. I then quickly removed the U-tape by pulling on the handle as shown in figure 2, and then I verified the imparted charge on the U-tape by hanging it from the table and placing my hand close to it as seen in figure 3. The next step of the lab was to observe the interactions between the 2 U-tapes to determine the charge. I observed that the U-tapes repulsed each other and the U-tape was attracted to the negatively charged plastic pen, indicating that it was positively charged. The next step of the lab procedure was the experimental setup. I placed 2 shoe boxes close to one another and stuck one end of U-tape on each box as shown in figure 4. Then I created a second U-tape and I attempted to float the first U-tape by using the electric force interactions between the 2 U-tapes as shown in figure 4. I then recorded the distance between the tapes at the moment I observed flotation. The results of my experiment are noted in this data summary. I determined the length of the tape to be 0.2 meters, the mass of the tape to be 0.0002 kilograms, the separation distance between the tapes to be 0.035 meters, and both the gravitational force and electric force to be 0.00196 newtons. For the programming portion of this lab, I created a computational model to determine the magnitude of charge on the tape. The model yielded the following output, and I calculated the magnitude of charge as 6.88 times 10 to the negative 9th coulombs. I made this model under the assumption that each U-tape had about the same amount of charge evenly distributed along its length.
To begin setting up my computational model, I began by inputting some constants and observed values including mass and estimated net charge on one tape. I then went ahead and copy-pasted my electric field function from Lab 0 and used the given line charge function to set things up.
For the iterative portion of this lab, I began by initializing the electric field in the for loop to be a zero vector. I then found the electric field at each location on the top tape due to each point charge on this bottom tape by using the E-field function. I then found the electric force at each location by multiplying that calculated E-field by the point charge. I added up all these individual electric force vectors to calculate the net electric force, and then I used the bottom portion of the code to create vectors for both the electric and gravitational force.
Going back to the original lab output, I determined the value of 6.88 times 10 to the negative 9th coulombs by changing the value of Q until I observed that the magnitude of electric force was equal to the magnitude of the gravitational force. Moving on to the lab questions, if I had modeled each tape as a single point charge like I did in the previous lab, I would have arrived at a single point charge model estimate of 1.6 times 10 to the negative 8th coulombs for the amount of charge on each piece of tape. In contrast, the line charge model or computational model estimate is 6.88 times 10 to the negative 9th coulombs. It is obvious that the estimate determined by the computational model is much smaller than that determined by the single charge model. This is the case because the single point charge model treats the entire length of tape as being one single point charge located at the center, whereas a computational model iteratively sums the charges along the length of the tape. The value determined by the computational model is more likely to be closer to the real value because it more accurately represents the tape as being a length of charges rather than one charge located at the very center.